Hi everyone and welcome to our SPM UASA in class for Maths Form 4 Chapter 5. Since our marathon is already end, so today we just continue for our lesson for Form 4 Chapter 5. This is called network in graph theory. That's different now, different thing. In our science computer, we learn about network. Today, we learn network in graph theory. So we can use graph to represent network. So the definition of the graph is interpreted as a series of the dots which are either linked or non-linked to one another by lines. So that is the definition of the graph. But today we focus on network. So a network is a graph that has at least one pair of the connected vertices. So dots are known as vertices and lines are edges. You can see here the dots are known as the vertices and the lines we call as the edges. The P, it is future, we call as the dots we call as the future. And we can represent the graph by using dot representation. V we call as the vertices. G we call as the graph. Okay, V is the set of the dots, or we can say that vertices. Okay, what is the use of this one? To let you know, okay, on the dots, what is the name of the dots? Okay, later on we will know when we use the dots and also the lines. Okay, V is called as the vertices. Okay, E we call as the edges. We can use N and V to determine the number of the vertices and E to represent the number of edges. And if have vertices and lines, we call edges. Okay, we have degree. If we have vertices, we have lines, of course we have degree. Degree is the number of edges that connect two vertices. The sum of degrees of the graph is twice the number of edges. The formula is this one. The sum of the degree of vertices equals to 2, twice of the number of edges. And we can say that the small v actually is the number of vertices. The small v is the element of the V, the big V. We can interpret the graph using many types of graph. We learn. First one is simple graph. A simple graph has no roots and no multiple edges. The sum of degrees of the graph is twice the number of edges. Okay, just now we learned about the formula. So the sum of the degree of the vertices equals to the twice number of edges. There is a complicated graph we call as multiple edges and loops. Multiple edges involve two vertices. What happened here? First, we have one line here and another line here. Okay, means these two coordinates have two same relationship, but their position different are different. Or we can say that loops one vertex, but it can connect at the same time. Means the one vertex connect with the same vertex, and each loop will add 2 to the degree, because the vertices go out from here and go in again to original places. So we tambah 2 lah. Kita tambah 2. That's for bahasa Melayu. Okay, kamu just ingat benda ni. Kalau ada berbilang tepi, maksud dia ada 2 vertex pucu, tetapi 2 pucu yang mewakili 2 garis, okay, arah yang sama, tapi okay, benda line yang sama, tapi arah dia tak tentukan. Tapi untuk gelung maksud dia akan keluar dari koordinat ini, pucu ini, dan balik kepada pucu yang sama. In, out. Kita akan guna benda ini untuk pergi next level. Ini adalah next level. Okay, graph kita ada multiple edges, loops, or single graph. And also, graph also can interpret to become directed, undirected graph. Okay, what is the use to determine that? Okay, the relation between the two vertices. What is the direction? For directed graph means the backward direction. Okay, if undirected graph means the simple graph or not simple graph, and also no direction. You can go in and out in any way, but for directed graph, your degree only have 1. Okay, means the one same degree. Okay, you only can move like this, but you cannot go back like this. That is called a directed graph. Okay, and both graphs have multiple edges or loops or not. That is called directed, undirected. Next level, weighted, unweighted graph is very big now. Okay, weighted graph and unweighted graph means the line can be represent something. For weighted graph, okay, we have value or weight. For example, distance, time, cost, current. Okay, for unweighted, nothing. Nothing, no value, no weight. Okay, and also the edges relation to information like draw hierarchy, floor mat, tree mat, bubble mat. If you see any bubble mat or tree mat, that is called edges. The line called edges, and both vertices that connect with the edges we call as the graph. Okay, it's called bahasa Melayu lah. Okay, and now we learn about subgraph. Okay, a graph can divide into different subgraph, and subgraph also can promote some subgraph become a tree. Tree is a graph. Tree of a graph is a subgraph of the graph. So for subgraph means the graph, original graph, I divide anyway. I can divide A point, B point, become a new graph. That is called subgraph. Okay, its original place also can, but you cannot switch the vertices. If you switch the vertices, that is not a subgraph for the original graph. And also for original graph is also a subgraph that is already written in the textbook. You can refer to it. For tree, remember, no loops, no multiple edges, and number of these vertices equals to n. Number of edges equals to n minus 1, and each is 1 to 1, no 1 to many. Okay, one vertex can go to another vertex, but cannot double it. Cannot double and vertex cannot go back to itself. Right? That's why you call no loops, no multiple edge. So what is the use for this chapter? Actually, we can say this chapter maybe currently not useful, but it tells you the relation, okay, between this and this. Okay, for example, relatives, your relatives, you need to know what is the relationship between this guy and the other guy. That is called network. So here I prepare some questions with you, and all the question involves graph, involves tree, involves unweighted graph, weighted graph, and also I will let you to draw the network, draw the graph. So that's all from today. We will see you in next chapter. Goodbye.